Good afternoon, DevOps Days Cairo, and let's get right into it. Like she said, this is about what got you here won't get you there. We've made a lot of progress. We've made a lot of accomplishments. I mean, DevOps is a little over 10 years old, and we've come really far. But a lot of our success doesn't necessarily mean that that's where we're going to go next. And this has been a year of change, to put it mildly. A little quick background. This talk isn't about me, but just for some perspective, I'm the lead organizer for DevOps Days globally across the world. I get to help events like this happen everywhere, which is very, very exciting. I founded the Chicago version. We just had our 7th instance and our first virtual one. So I feel the challenges of turning this event virtual. And I think your organizers have done a great job so far. I host a podcast called Arrested DevOps. And back when we could get on airplanes, I used to travel the world giving talks like this. I am a transformation specialist at Red Hat, which means that I help especially government agencies in their transformation on how they can get better at this kind of work. And if you have any question about my commitment to DevOps, my car's license tag actually does say kubectl, and we can talk later maybe in the Q&A about how to properly pronounce my license plate. So why are we here? Why are we here today? Why are we having these conversations? And we might be wanting to talk about things like Kubernetes or microservices, continuous delivery, containers, words like cloud native. These are all really key things. But is that why we are here? Are we here to talk about systems like that? Or are we here to talk about people at a global perspective, this large organization, if you will, that we call the human race? But then we think about the teams, the smaller groups that we work in together to try to provide value, and even all the way down to our families and our future and the next generation. This is why we're here. And then I started to think a little bit about why our organization's doing the work that they're doing. And so I went to take a look at a couple different agencies and companies to see what was important to them. So here in the United States, the Postal Service, I looked up, I said, what are the strategic goals of the United States Postal Service? But then I said, well, what about, maybe that's just government. What about large enterprises like JP Morgan Chase, one of the largest banks in the world? Looked at their mission statement. They want to be the best financial services company in the world. And we talk about the DevOps darlings like Netflix. What's Netflix here for? And it's providing stellar service and growth. There's all of these missions are different, right? The US Postal Service, JP Morgan Chase, Netflix, they all have different reasons for what they're trying to accomplish. But there's one thing they all have in common, which is not one of them has anything to do with containers or Kubernetes, right? None of them list that as a strategic goal is to deploy a whole lot of containers. Technology is an enabler. It is not the reason. Technology is something that gets us to accomplish those goals around the human village, around our families, around our customers, around our constituents. The only thing that is constant, you may have heard this before, but the only thing that is constant is that things are not constant, is change. Change is continually happening. So if we think about cloud and how cloud has come up, and then this is one of the definitions, kind of the standards board definition of cloud computing. And I want to pull out a couple of things about this that I think are really important to think about in our conversation. It is on demand, right? It's rapidly provisioned. So when we think about on demand and rapidly provisioned, there's this idea called Jevons paradox, which says that as a resource becomes more efficient, it becomes easier to consume, we actually consume more of it. And Javon was talking about coal and about fuel, that as we got better and it became cheaper to consume fuel, we actually consume more of that. Well, hello, cloud. Same thing. When we look at back in the 80s, you might have two things. You'd have a couple of mainframes maybe. We moved in the 90s when I was getting my feet wet in this. We had client server. So you might have a bunch. And then we started to build these big data centers, right? Where we had lots and lots and lots of blades and some virtualization going on, rise of VMware. And now we're here in the age of cloud. And it is so much bigger. We cannot wrap our minds around all of our nodes. I mean, I remember there was a time I could rattle off every server in my organization. I couldn't even tell you how many kinds of servers I might have in my organization today, much less how many instances and what they're named. So this is the truth, right? Cloud has really overwhelmed us in IT. It's just too much. It's so overwhelming. But what are we going to do about that? Because again, according to Javon, this is happening, right? We can sit and we can wring our hands and complain and everything, but this is happening. So how do we work to not be overwhelmed? How do we move into the next phase of what we need to do to provide that mission? And I want to take a little bit of a thought about why. Why are we doing this? We're going to talk a lot later today about how, and how is really important, but we need to understand the point, because we're talking about doing a lot of work and we need to understand why we're doing that work. Well, I can't give a DevOps talk without throwing up a slide of a bunch of shipping containers. And I'm going to talk about containers right now, but maybe not Docker containers, maybe not orchestration, but let's take a minute to talk about these containers, these actual metal boxes from which we took the metaphor that then became Linux containerization. So if we look at the value of global exports over the last couple hundred years, and this is the a time series index, right, of the value of exports across the world, basically relative to 1913, right? And we take a look and it's really, really low, and it's very, very stable for a very long time. And then something really interesting happens. As across global trade, there's an adoption of standardized shipping containers, those big metal boxes that go in every single Docker presentation you've ever seen, right? Sometimes you might have seen the ones where they're falling over. It's kind of fun. But we see that insane hockey stick growth that happens, and it happens at a really specific time. It happens during this time between the late 1960s, kind of up until the mid 1980s. And this is when containers were really becoming adopted worldwide. And that's where we can see what had been a very stable, very flat for almost 100 years amount of global trade. It just goes off the charts. And it's because I believe in complex systems, but this is a very, very major contributing factor to this dramatic change in global trade. And to look at where this happens, if we look at the impact that it had, if we're looking within, specifically in this case, these are numbers within Europe, before the container era, the productivity of your dock labor, they could move about not even quite 2 tons an hour, versus just even a few years later, 30 tons an hour of goods was being moved inside a port. The size, your average size of a ship, almost tripled in tonnage. Another interesting thing is the number of ports became very concentrated. Before the container, there was really 11 major ports around Europe. But then by 1970, that was really down to 3 big major ports because of that consolidation. But then the last one that I think is really interesting is the amount of capital that was locked up as inventory during transit. So the amount of money that was not usable because it was being reflected in stuff on a ship somewhere, it was cut in half. It went from £1 per ton, from £2 per ton to 1. This is a dramatic change in the entire way that global trade worked. So containers, these metal boxes, they disrupted the entire supply chain of the globe. The way every business worked was changed because of this. And we had to change lots of things. The way that we move things across the roadways, trailer trucks are different because of shipping containers. The way that rail worked, instead of loading things into boxcars, you just move that container around. And even the way that ships work, we went from these smaller shipping vessels to these massive, massive container boats. Every bit of how we move things around this world changed because of that one simple innovation, which was the shipping container. So that entire supply chain was disrupted. We had to retool. Like I talked about, we kind of just talked about that. We needed new trailers, new train cars. The ways that we designed our ports are completely different. And this happened in just a few years. We had to retrain. So dock work, which had previously been mostly manual labor, pick up this box, move it over there, it's become much more logistically challenging to think about how we move things around. So all of our workers, our entire workforce around this had to learn new skills. And then we had to, most importantly, rethink the entire business model, how we charged for things, the pricing, those things all became different. And our processes had to change for how we handled cargo. Well, cloud and containers and all of this fun stuff we're talking about for the rest of the day, they've disrupted IT in exactly the same way. So whoever came up with the idea and called it a Linux container didn't really know, but they came up with a really darn good metaphor for a complete industry-changing innovation. But we have to retool. We now are thinking about on-demand infrastructure. Ideas around how we're shipping software with continuous delivery. We have to measure everything. We need new tools for this. We have to retrain. All of our very skilled workers who are very good at working a certain way have all sorts of new skills, both around all this new technology, but again, the different ways of working. It's not just learning new syntax and learning new engineering details and implementation. It's also new ways of doing our work. And then we have to rethink. We rethink how we deliver. We can't do these quarterly releases. We think about site reliability and the SRE model. We have to change the whole way that we think about the culture of our technology organizations. Think about how incidents need to be blameless and how we can learn from them, and these ideas around iterative development. So what is DevOps? We're here for DevOps Days, so let's lay a couple definitions on there. And DevOps is one of those things that, you know, it's like I don't know art, but I know what I like, or I know it when I see it. But let's put some words around it. So one that I really like, there's quite a few. You know, you ask 12 different people on Twitter for a definition of DevOps, you'll get 15 different answers. But here's a couple I like. So Donovan Brown over at Microsoft has said that it's the union of people, process, and products to enable continuous delivery of value. Right. So the things I want to pick out about there is that it's people, process, and products. It's all those things, but it's about delivering value. And then Andrew Clay Schaefer, who will be is my colleague who's going to be speaking a little bit later today. I asked Andrew, I said, Andrew, I need a definition of DevOps for a slide that I'm doing. And this is what Andrew told me. And he said, it's optimizing the human experience and performance of operating software with software and humans. And I love this because it's software and humans. I'm going to talk a little bit later about socio-technical systems. And that's the thing. This is not a technology problem only, and it's not a culture and person and people problem only. It's that union. So both of these talk about that. And that's why they really have resonated with me. It's the people, it's the software and the humans, not one or the other. You can't solve it with just one of these. Going back another very common over the last decade, we talk a lot about this idea of CALMs. It started out as CAMs from John Willis and Damon Edwards, and then later we added the L. But what are these things? So CALM stands for culture, automation, lean, measurement, and sharing. Now, the order of these things in the list don't matter. They're only put in this order because it spells a word, which maybe makes it easier for us to remember it. You might like clams instead of calms if that helps you remember it better. But these are kind of 5 key tenets of the conversation around DevOps, and each is just as important as the other, and they all interlock with each other. So what do they mean? Like, everybody can mean different things. Culture is pretty straightforward to me. It's also the hardest one, but we're thinking about people over process, which comes from the Agile Manifesto. It's a focus on learning. And this is one I really want to reiterate. We are continually getting better, but we need to have a focus. We need to prioritize how are we learning as individuals and as an organization. The idea of psychological safety. This was Google had Project Aristotle, and they went and they looked at the highest performing engineering teams in Google and said, what makes them so great? And the one thing that was consistent is these teams had a high level of psychological safety. And psychological safety is fundamentally not being afraid that you are going to be punished or reprimanded or made fun of for speaking up. And it's harder than it sounds. And ideas can come from anyone, right? The chain of command needs to go away, right? Everybody. I always like to say that, junior engineers are some of your most powerful resources in your team, because they'll ask the questions that those of us that have been in the org for 10 years will never ask. These ideas can come from anywhere. It doesn't matter if you've been here for 2 weeks or 12 years. And automation. This is the one that we tend to focus on when we think about doing DevOps. It's almost always about automation. And that's because this is the fun part. This is the part where we get to play with tools and configuration management and Kubernetes and all sorts of scripting, and computers do what you tell them to most of the time. But what does it mean? It's automating your entire software delivery lifecycle, the whole way that you go from commit to cache, from idea to having it in front of someone that's getting value. So they can be things like infrastructure as code, thinking about continuous integration, and continuous delivery. These are all ways that we accomplish automation, consistency. We cannot work at the scale we're talking about if we're doing things by hand. It just doesn't work. Lean. So lean is really an operations management school of thought. Around primarily comes from the manufacturing side of the world, but there's a bunch of principles that we can get from the lean movement and the lean approach that really help us in our side. We think about this was really popularized by the Toyota production system and how they build cars very effectively. And it's really a lot about removing waste from our processes. Where are we not providing value and just spinning our wheels? I'm going to talk a little bit more about lean in a minute. Measurement super matters. This is the only way we know that we're getting better, and they can be performance metrics or process metrics or people metrics. And those are some harder ones because you can't put a Nagios agent on your engineers. Trust me, I've tried. And then finally, it really comes down, I'm having a slide problem. There we go. And a lot of this really, if we look back to the Accelerate State of DevOps report, we can see that survey data is very, very powerful to understand. And the beautiful thing about everything that Dora did and Accelerate did was really wrap some science around this so we can see the numbers. And then sharing. This is really about thinking about adopting the principles of open, whether that's inside your organization or amongst other organizations, right? J. Paul Reed had his entire thesis about sharing postmortems, and he discovered that the larger the organization, the less likely teams were to share the results of their postmortems, which is really the opposite. I like to say that a write-only postmortem doesn't help anyone. We have to share it. And sharing outside your organization just helps everybody get better. Nobody is going to disrupt Netflix by knowing how they ship software, right? Their secret sauce is something different. And this helps improve our industry overall, and we all get better. So the thing is, the old way is not sustainable. We can't throw a bunch of metal shipping containers on a sailing ship. Yes, we could move things around the dock with the way we used to do things, but it's not going to get us where we have to go. What got you here will not get you there. We've been very successful. We should be proud of ourselves. You should be proud of everything you've achieved in your career so far. And now I'm going to say, what have you done for me lately? How are we going to get to the next part? We have to evolve our supply chain, just like we did when we were disrupted globally by shipping containers. And the place to focus because it's the part that we don't think about the most, is around culture and lean. And I want to talk about how we can do that for a minute, right? So here's the thing. Startups aren't the only disruptor. I spend a lot of my time working with government agencies, and they will tell me, well, I'm not worried about Amazon coming and disrupting how we provide health and human services in my state. I'm not worried. Uber is not coming after the internal revenue system, the tax system in the US. But startups like Netflix and Uber, these are not the only things that can cause disruption. COVID-19, this kind of made a lot of plans go right out the window. We had all sorts of things we wanted to do in 2020, and most of us haven't been able to do any of them, both individually and as organizations. I've seen the amount of massive change that has had to happen in these government agencies that I work with in terms of demand and new services that they have to be able to provide. They have been disrupted by COVID-19 the same way that your store might be disrupted by Amazon. Everyone's been disrupted by COVID. So how do we do something about that, though? Is the problem that, well, we didn't have a plan for a global pandemic? Well, maybe as a government, that's a problem. But as an organization, you can't plan for everything. And this is where we talk about the idea of being resilient. Okay. So David Woods has a great paper, and I'll link to it in the slides later, called Resilience as a Verb. Resilience is something that we do. It's not necessarily something that we have. And that means we have to take action to be resilient. But resilient doesn't mean that we are prepared for everything that might possibly happen. Resilience is how do we respond to things we don't understand or we didn't predict. So when we think about resilience, there's 4 ideas that are really critical to really understand this. And resilience is different than reliability. So we think about the ideas of rebound, robustness, graceful extensibility, and then sustained adaptability. Don't worry, we're going to talk about each of these. So rebound, what is this? This is how you return to normal after a surprise. How quickly can you restore service after something happened that you didn't expect? That's rebound. It's also really work that's done ahead of time. So you're ready, you're prepared to have that ability to rebound. Robustness is what we think about a lot if you ask the average person what they think resilience means, they're usually thinking about robustness. And this is the ability to withstand disturbances that you know about. So this is things like high availability, right? Auto failover, stuff like this. That's being robust. That's the kind of thing we've been doing in ops for decades. But that's not being resilient. Robustness is helping live to resilience. This is also sometimes called the known knowns. These are things that we know that we know that we know, right? That's robustness. It's important, but it's not going to get you all the way to being resilient. Graceful extensibility is that ability to stretch when there are challenges to those boundaries that you understand. When something happens you didn't model for, can you stretch? Can you flex to absorb that? And this is done via people. This is opposed to being brittle or fragile, which means, hey, if a thing happens we didn't plan for, everything goes to heck. That's being brittle. Graceful extensibility is the opposite. And then this all goes into sustained adaptability. This is recognizing and managing this adaptive capability over a long time scale. How are we continually getting better at being resilient rather than just in the moment? How is it part of the culture of our entire organization and socio-technical system? So why does culture matter, though? Well, here's the thing. Tools influence culture. The tools you pick and implement will have an impact on how you think about working, but then the way that you work influences those tools, right? So you can, Conway's Law, the architecture of your application is a reflection upon how your team communicates. You may have heard the saying before that says you ship your organizational chart. Your product is a reflection of how you work together as people. And this is what matters. These are what we call socio-technical systems. They're made up of people and they're made up of technology. It's not just technical. It's not just build a failover group and you're good to go. How do the people respond? And true resiliency is coming from the socio part of socio-technical. True resiliency comes from how the humans are adapting and having that graceful extensibility and that adaptive capacity. So, why the culture, right? This is fundamental to how teams operate and interact. This lets people define how they want to work and interact. And this also gives you some easy wins that show success. You can say, if we do, my team works this way, and look at how much better we are at shipping because I've got a bunch of data. And this reinforces all those other principles. So why do we have silos? Well, like, organizations create these groups and these walls for a reason. They don't do it because they're bad people, right? This comes from history. They create these walls and these silos for protection, right? They produce these inoperable groups to protect themselves because maybe there's a lot of blame. They need to be able to show what they do. And this is what happens with this idea of sort of the wall of confusion that Andrew Schaefer likes to talk about. When we're kind of throwing things over the fence, this is the result. We just build bigger fences. But when we think about an open organization, this changes the way that people work into these multidisciplinary teams that have accountability and responsibility to each other. And this is about when we think about being more product focused than project focused. This allows us to have faster iteration. We have a better understanding of our problem domain and what our users need and desire. So feedback loops are really key to DevOps. We talk about them a lot. And having the visibility into those feedback loops only works in a product-oriented, cross-functional team. In the resilience engineering side of the house, we like to talk about the difference between the blunt and the sharp end of an organization. So the blunt end is usually higher up in the organizational chart. They're your leaders. They tend to be removed from the experience. They aren't having their eyes on everything all the time. They don't have their boots on the ground. And but oftentimes your blunt end, these are the people making decisions upstream from where the work is getting done. And then the sharp end, these are the people directly engaged in the work. If you hear the phrase chop wood, carry water, we're talking about the sharp end. We're talking about your practitioners, you're talking about your engineers, you're talking about the people that actually are doing the work, and they have a really good insight into how that work gets done. So why is the sharp end important? Well, the sharp end, they're constantly building and destroying systems, so they understand them. They have very strong signaling amongst each other. They know how to communicate. And they know how to improve systems based upon the strain. And the thing is, teams like this will do all of this naturally if they are given ownership. So I'm starting to run a little bit short on my time, so I'm going to go through this a little quickly, but I will have a link to my slides at the end, and you can look at this a little more. But why does Lean? This gives a hyper focus on what problems to solve and how. And this helps us know, what should we automate? How are we going to measure? How do we share? And this influences other ways to work, whether it's agile, infrastructure as code, it goes into all of that. A key idea in Lean is this idea of value stream mapping. And I invite you to take a look at these slides and the link later to look at it in greater detail. But just looking at, this is the idea of someone who's building a bicycle. And we can see, if we go through the stream, that a lot of the individual workstations might take only a few seconds, but there are very long times of waste in between each one. So while building a bicycle only takes a little bit less than 2 minutes of actual work, it takes 40 days to get to that point. And when we do a value stream map, we can see where this waste is happening, and we can look for different ideas on how to change it. I want to wrap up with talking about how do we scale this across our entire organization. It's about the people in the teams. And at Red Hat, we talk about the 5 elements of transformation, which is more than just agile software development, but we're talking about leadership, product, architecture, and operations. And I just want to show what this looks like. None of these, they aren't necessarily teams, they're ideas, and we can see how they all work together. on a continuum of change versus adaptive capacity, tactical versus strategic. And it's one big feedback loop is where all these things come together. So to lead the 5 elements that I talked about there, they're key to being able to scale through your organization. A small team can be successful, but if you want to get your larger organization going, you need to think about those larger elements. So remember the mission. Why are you here? Remember that DevOps is holistic. It's across more than just one part. It's all of the elements. You don't want to overemphasize one area. It's very easy and very delightful to say, I just want to pay attention to automation because that's fun. Try to avoid that. If you really focus on culture and lean, the rest will fall out from those principles. And think about your actual delivery supply chain. Thank you for letting me be a part of your afternoon and part of this great event. You can find me on Twitter at Matt Stratton. These slides are available online now if you go to speaking.mattstratton.com, as well as a couple other great links to reinforce this. If you like podcasts, check me out at Arrested DevOps. I also host a fun party game once a month, an online game show of DevOps themed comedy called DevOps Party Games. Would love for you to come visit us there and enjoy the rest of this amazing event.